Start.
Right, my name is Lakshman Kumar. We are going to discuss ion exchange method. Ion exchange resins are insoluble in water, cross-linked, long-chain organic polymers with a micropore structure, and the functional groups are attached to the chain responsible for the ion exchange properties. Resin contain acidic functional group like COH, SO3H are capable to exchange the H plus ions with other cations which comes their contact. Resins containing basic groups like NH2 are capable of exchanging the anions with other anions which comes their contact. Now we are watching cation exchange resin and anion exchange resin. See here, this is a polymer which is linked horizontally and vertically. This one is called as cross-linked polymer. Its name is polystyrene. See here, CH2 bond CH, CH2, and this one is linked with hydrogen, and later this one is linked with SO3 minus H plus. Here also the same SO3 H plus, and here another SO3 minus H plus, SO3 minus H plus. These are responsible to holding the cations like H plus. Okay, when impure water come in contact with the SO3 minus, the water contains the hardness causing salt like positively charged species, calcium and magnesium. Ca plus type of ions are cold here, and the H plus which is cold here is detached when they cross here. Okay, so this SO3 minus negatively charged species is responsible to hold the positively charged cations. Okay, similarly, anion exchange resin is also similar to the cation exchange resin, but the attachment group is different. Here, holding group CH2 and amine twice plus quaternary ammonium ion. This one is responsible for holding the anions. When the raw water which is having negatively charged anions like chloride, sulfates come in contact with this group. This one holds the incoming chlorides and sulfates and leaves the OH minus ion which is going to here. Okay, finally from the cationic resin, H plus is released and anion exchange leaves OH minus ion and holds Cl minus SO3 minus negative charged gas. These are the resin structure of cation exchange and this is the resin structure of anion exchange. Simply we indicate anion exchange with R rho indicates anion exchange. Okay. Now we will discuss the anion exchange process dynamically. So see here, here we are presenting a structure of ion exchange process instrumentation. In this instrument, here the LOT passes of impure water into this container which is already having cation exchange residue. Another cylindrical cylinder containing anion exchange residue. Anion exchange residue. First of all, we allow the passes of impure water into this cylindrical container. The impure water contains, you know that, calcium chloride, magnesium chloride, calcium carbonate, magnesium carbonate, calcium bicarbonate, magnesium carbonate, and these salts have both the positively charged ions and the negatively charged ions. Okay, when we allow the passes of this impure water on the bed of cationic resin, this cationic resin already holds H plus ions as seen previously. Okay, but when this impure water come in contact with cationic resin, this one holds the positively charged species like Ca plus, Ag plus, and any other else. This one holds all those positively charged ions and leaves already bonded H plus atoms here. So the eluted water contains H plus ions and negatively charged ions Cl minus, SO3 minus, etc. carbonates. Okay, and these are later on passed into another cylinder. Okay, this one already packed with anion exchange. We know the function of anion exchange. The anion exchanger holds negatively charged species OH minus ion. When this water flows on the bed of anion exchange, this one holds negatively charged ions like chlorides, sulfates, carbonates, etc. and leads to OH minus ion. And you know very well, this cation exchange does not hold the negatively charged species, and this anion exchange doesn't hold the positive charged ions. So finally here, cation exchange leaves OH minus ions and H plus ions and Cl minus ions. H plus ions, Cl minus ions. And anion resin leaves H plus ions, OH minus ions. Finally, here H plus and OH minus both are combined together and forms water molecule. These water later passed into degasifier chamber to further purify. In this degasifier chamber, we remove the dissolved gases which are present in the water. Okay, the purified water contains a very less amount of hardness up to the level of 2 ppm. You see here the mechanism involved in this reaction. In step 1, 2 RH plus. That means you know very well. R means resin, H plus means cation exchange resin. When cation or calcium or magnesium come in contact with the cationic resin, these ions just exchange takes place. If you understand the exchange word properly, the mechanism is very simple. So exchange means the H plus cation is present replaced with the calcium ion and a magnesium ion here. So later this resin holds the calcium ion and leaves H plus, and similarly this one holds the magnesium ion, leaves H plus. So in first step, or when we allow the process of raw water on the bed of cationic resin, that cationic resin holds the positively charged species like Ca plus 2 calcium, Mg plus 2 magnesium ions, and leaves H plus ions. Okay, and also leaves negatively charged ions species. After cationic column, the hot water is passing through anionic column in a variable. So here R dash OH minus. This one indicates net anion exchange resin. This anion exchange resin initially holds negatively charged species OH minus, when the chloride ions, sulfide ions, carbonate ions, negatively charged species, when coming in contact with the anion exchange resin, the anion exchange resin holds the negatively charged species and leaves OH minus ion and leaves OH minus ion. So finally, H plus ions, OH minus ion come in contact and combine together forms the water molecule. In this process, you observe that in step 1 we remove positively charged ions. In step 2 we remove negatively charged ions. Okay, so that's why we call it is a deionization process. See here, one more step is there, that is method of regeneration. The radiation, when capacity of anion or cation resin to exchange ions are lost, then they are said to be exhausted. That means we purify a lot of water by using this technique, and finally the cation exchange resin and anion exchange resin lose their capacity. That means to exchange of cations and exchange of anions. And then to regenerate, that means to enhance the exchange capacity of anion, resin and cation exchange resin, we can recharge them by using a suitable solution to regenerate cation exchange resin columns. We use dilute acids like HCl hydrochloric acid, H2SO4 sulfuric acid. The dilute solutions of HCl and H2SO4 is useful to regenerate the cation exchange column. Okay. To recharge or regenerate the anion exchange column, we use alkaline materials like NaOH or KOH solutions. So you may observe in the picture this side tank contains alkaline solution, NaOH solution or KOH solution, and the tank which is attached to the cationic resin contains dilute HCl and H2SO4. When we allow the passage of these acids on the bed of cationic resin, you know, after purifying some water, the cationic resin is completely filled with cations of calcium and magnesium. Okay. So when we allow the passage of these acid solutions on the bed of cationic resin, the solution contains H plus ions Okay, more number of express ions. When the LOD passes of these express ions on the bed of cationic suppose the cations, again the ion exchange process will be done. That means the bed contains, see here, reaction after, you know very well, after purifying the water, the original cation exchange resin H plus or H plus is converted as R2 Ca+. That means this bed is filled with calcium magnesium. We want to recharge or regenerate this calcium or magnesium occupied cation exchange. To recharge this one, we use acidic solution, dilute H2O or HCl solution. Here also exchange takes place. So calcium ion comes out, H plus and force again. The resin leaves the calcium ions and H plus and force the H plus ions. Similarly, anion exchange resin also regenerated by Postman's ions. When we allow the process of alkyl solution on the bed of anionic exchange resin, the resin holds negatively charged species OH minus ions and leaves the SO4 2 minus calcium. And these are comes down and we send them into washing sink. We open the top of tap here at the time of washing or we get the process of anionic synthesis, cationic synthesis. We allow the elements to the sink. Now we are going to discuss the advantage and disadvantage of the ion exchange method. You know very well, this ion exchange method is useful to purify highly acidic and alkaline water, and also this method is highly suitable to purify boiler water because high pressure boilers we fill the water without hardness. That means it produces water of very low hardness ppm. And disadvantage, the equipment is costly and more expensive chemicals are needed. If second disadvantage is if water contains turbidity, then the output of process is reduced. The turbidity must be below